All right. Working? Kind of. All right. Let's see how this goes. I'm just going to turn my camera off because my computer's a little slow this morning, but we are back from spring break and we are going to talk about properties of exponents. And and I feel like we did not. We did not talk about properties of exponents yet. And then we are going to talk about, did we really know? And then we're going to talk about equations and angle relationships, which may be a little bit of review, we'll see. And then I have these two checkpoint assignments. Those are things we've already covered, but next week is MCAP week. Okay, so you are going to want to make sure that you stay fresh on that and you're going to be in good shape. Okay, we've been working really hard. I mean, you can look at all these assignments, and if you've been following the system, then you have been putting your pedal to the metal. All right, so good job. Sign in. Make sure you sign in. I don't want you to start working and lose all that progress. How many people have done that? Okay, so let's talk about properties of exponents. Let me find my annotation tool. Okay, so we have, I know that we talked about properties of exponents. Oh yeah, right here, okay. We did multiplying and dividing powers. We did power to a power. And okay, then we had spring break. And so now we're doing checkpoint of exponents. So I don't need to rewrite all the rules. You know, we started those last week. But we can talk about negative exponents. Okay, so we did not talk about that. Negative exponents. What could that mean? So 7 to the negative second power. Is that negative 49? Well, let's see. If that's true, I mean, I guess it'd just be negative 7 times negative 7, but that's positive 49. So this is not true. Right? 7 to the negative second cannot be a negative number. So what did they do? They said 7 to the negative second will represent the reciprocal of 7 squared, or 1 over 7 squared. So you could check it out. 7 to the negative second is actually equal to 1/49. Okay, so anytime you see a negative exponent, you can just flip things around. So 1/5, if we have that to the negative fourth, we can do the reciprocal. And the reciprocal of 1/5 is 5 over 1, or just 5, right? I mean, not to the negative fourth, but now to the positive fourth. So this right here is the same as 5 to the fourth. Oh, so it's equivalent to the 5 to the fourth. So 1, so let's drag that. Okay. Now what about 5 squared over 5 to the 6? There we're going to subtract the exponents, so that would be 5 to the 2 minus 6, which is 5 to the negative fourth, which we just said would be 1 over 5 to the fourth. So that is not equivalent to 5 to the fourth, that's equivalent to 5 to the negative fourth. Okay, so that one goes over here. How about negative 2 times negative 2 is positive 4. Negative times a negative is a positive. And this one, 6 minus 2 is 4. So that would be like that. So all we needed was our rules of exponents from the week before break, where we are talking about things like this, where that we would multiply the exponents. Be 5 to the 6, 2 times 3, right? We needed to know, well, we didn't really need to know this one, but 5 squared times 5 to the third would be 5 to the fifth, because here we are adding the exponents. And of course, 5 to the third over 5. This is 5 to the third over 5, which would be 5 squared, because here we could stick a 1 right there, and we are subtracting the exponents. So that's from last week, properties of exponents. Okay. And so now we have the negative exponents. Negative exponent 7 to the negative squared is 1 over 7 squared. So these are my little examples. Property of examples. Oh, okay. So 9 to the negative fifth is 1 over 9 to the fifth. And 9 to the ninth over 9 to the fourth is 9 to the 9 minus 4, which is 9 to the positive 5. So I'm just taking these and simplifying them down so they have no negative exponents and only one base. 9, and so here I'm going to add the exponents 4 plus negative 9, which is negative 5. And here I'm going to multiply the exponents, which is 2 times negative 3 is negative 6. So that's definitely not. So which two are equivalent? Well, this one, 9 to the negative fifth, would be 1 over 9 to the positive fifth, right? So these two are equivalent. The other ones almost made it, but not quite. Now let's do another one. 3 to the negative 10th is equal to what two numbers that could go here? And so here we are multiplying them, right? So we're asking ourselves, what two numbers multiply to negative 10? V times W. Well, not a whole lot of choices. But it says what possible values. So we could choose a number of things. We could say negative 10 times 1. We could say negative 2 times 5. We could say 2 times negative 5. We could say 10 times negative 1. And that's all I can think of. So I think we could put any of those in here. So, and they should work because they all work. All right. So that was just asking us to kind of figure that one out. And, this is cool. This is called a list of factors, which is something we do in other areas of math. All right. So here we are subtracting. So now we're asking ourselves S minus T equals 8. So what could that be? There's a lot of choices there too. So how about 10 minus 2? 10 minus 2 is 8, right? So could we make S equal to 10 and T equal to 2? Now, notice I couldn't have done 2 minus 10 because that would have been negative 8. All right. Oh my, look, my smart score is 60. Okay, let me do one more. M times 3 equals 6. So now this time we're adding. So that's got to be 3. Now there's only one answer, unfortunately. Okay, that's good. So you have some fun with that one, all right? And let's look at this angle addition, which is important because you're going to have a lot of equations to solve. And I think we are going to have a not that long ed puzzle video today. Well, we'll see. We're going to do transversals. Okay. So this is a right angle. I know that because of the little box there, right? angle. That's what this little box means. And that means it equals 90 degrees, okay? All right angles are 90 degrees. So that means this angle, which is 8x, plus this angle, which is 10 degrees, add up to the right angle, right? Which we know is 90, because it's a right angle. Okay, and if we were to name the angles RQS, which is the 10, angle RQS, the measure of angle RQS. And here, this would be the measure of SQT. SQT. What's the measure of angle SQT? Yeah. So SQT is 8x, RQS equals 10, RQS is 10. And the whole angle RQT equals the measure of angle RQT. So anyway, this is called angle addition. You want to learn more about it. And the idea is two smaller angles, when they're adjacent, put together, they can add up to a larger angle. And then we end up with an equation that we can solve. 8x plus 10 equals 90. So let's draw a line under that. Take away 10 from both sides. And now 8x equals 80. Divide both sides by 8. X equals 10. And so now I can answer all my questions about it. 8x plus 10 equals 90, and x equals 10. Wonderful. All right, so that was adjacent angles. And they looked like two angles that added up to a right angle. Now here, these are called vertical angles. Okay, so vertical angles are across from each other in a pair of intersecting lines, right? So vertical angles could be 1 and 2, or your vertical angles could be here across from each other. They don't have to be up and down, even though that's what vertical means. And vertical angles are congruent, or we could say the same measure. Okay, so that means that this angle right here is equal to this angle right here. So we would say 6x minus 4 equals 68. And now we have an equation to solve. Add 4 to both sides. 6x equals 72. Divide both sides by 6. And x equals, is that going to be 12? And so 6x. So now we got to choose an equivalent expression. So 6 2x equals 68. No, I didn't get that one. 6x equals 72. 6x plus 64 equals 90. What? 6x minus 4 equal. Oh, yeah. Right here. Okay. Sorry, guys. All right, and then x equals 12. All right. Now we're moving right along. And we can see this one is trying to trick us, but we have two intersecting lines, and we can see that we have one angle made up of these two things, and one angle is here. And so we can add these two angles together, x plus 8 plus x plus 8, and that's one side, and then the other side is 126. And we have an equation to solve. 2x plus 16 equals 126. Subtract 16 from both sides. 110. Divide by 2. X equals 55. So 2x plus, oh yeah, this one would work. Right here, 2 times x plus 8 equals 126, and then x equals 55. All right. So now this is going to be the last one we do, but this is what I was waiting for. When we have angles that add up to be a straight line. So we have this angle, and this angle, and all together they make a straight line, which is 180. So anytime angles add up to a straight line, then you are going to make an equation to solve that adds up to 180. And so we can now just go ahead and solve that. We got two like terms over here, 72 and 38. So I'll just do that math to the side. It's 110. So 5x plus 110 equals 180. Subtract 110 from both sides. 5x equals 70. Divide by 5. X equals, what is that? 14. So 5x plus 110 equals 180. And x equals 14. All right. Last one. So now if you have parallel lines cut by a transversal, so the line that cuts the two parallel lines is called the transversal. You set up more angles that are either congruent or supplementary if the lines are parallel. And that's what these two arrows mean. That means they're parallel. So within here, you have an interior, and then you have two parts to the exterior. Okay, so we want to look and see if we have angles that are the same or supplementary, adding up to 180. And so here is a pair of angles that are the same. Okay. And these are called corresponding angles. And corresponding are congruent. Okay, so then we would have an equation to solve like this. And there are several other angle pair names, but I'm not going to go over them all right now because I have gone over quite a bit already. So I think that's a bit overwhelming. Okay, so that's 63. So that's going to be 9, right? But what I want to do is get one more problem, just one more, and show you how we can use that corresponding angle relationship to find others. So here, 110 has a corresponding angle over here, and it's the one that's in the same corner. So we have corners here, 1, 2, 3, 4, right? So which one of the corners is the same position as the 110? That would be right here. Okay. So this corresponding angle pair relationship is very important. Corresponding angles. So like 1 and 5 are a corresponding angle pair because they're both in the top left. 2 and 6 are both in the top right. Do you see it yet? 3 and 7 are both in the bottom left, and 4 and 8 are corresponding. And so that's important because they're the same. So if I see a 110 on this corresponding, I can put a 110 over there. And now I have vertical angles. So I have an equation to solve. 3x minus 10. Add 10 to both sides. 120 equals 3x. Divide by 3. It's going to be 40. Is it gonna be 40? Awesome. And now here, look at that. Corresponding angle pair right there. So you know that they're equal. Okay? So go for it. Do everything you can on that. And I'm thinking that this week we are really going to focus in on getting 80s on our properties of exponents and our equation relationships. And if you end up with the 80 on transversals, then you're in good shape for next week's MCAP. If not, then we can make that a goal for next week in general, since we talked about it in Ed Puzzle. And then the rest of next week is going to be the NWEA skill plan that we set up at the end of the third quarter. If you didn't set yours up, please let me know. I'll give you your map scores so you can do that. And then, of course, go for 80s on our checkpoints, as we've already covered that material. All right, start working, and don't forget your traffic light problems for each. Bye.